everybody, this is Dan, aka Entertainmentwf, aka Page Wizard, aka blah. Anyways, and then we'll call this part 2 of whole brain emulation quacks. I just felt like making a little video response to a fellow named dan91709. Now, he doesn't support whole brain simulation, at least that's what he said, is that, well, I'm making this video because he's so dead wrong, and he thinks these crazy ideas about AI that are just not true according to theoretical computer science. Now, he may not have even proper understanding of how computation actually works. I don't know. Well, I'm just reading what he's saying. I try to answer his questions. I try to propose factual information to him. He didn't seem to understand it. So anyways, I'm going to address this because I found it just insulting to me that somebody's talking in a very condescending way to me, somebody that's studied this stuff for years, and somebody that has taken the time to understand and research this material before he went and presented it to you on a YouTube video. Now, with that being said, I know a lot about philosophy and science, and I know what you're talking about, Dan, here. It's ironic that you have the same username as my name. So I thought I would talk about this. Well, first off, you accused me of talking about the Turing test improperly. Well, no, I actually didn't. And nor did I even address the concept of failing the Turing test, or even passing the Turing test. I talked about Turing machines and computability. If you didn't seem to grasp that concept, the Turing machine is the most powerful computational model that exists. And nobody's ever proposed or even been able to create a machine more powerful than a Turing machine. That's just a factual fact. A factual fact. I can't even give you how powerful a notion it is to understand that a Turing machine is the most powerful computational model that exists. And there's no other model out there that's more powerful. And you claim that neural networks can't be applied to Turing models. Are you ridiculous? I don't know what you're talking about, because neural networks are typically Turing Complete. Yeah, that's right, it's Turing Complete. So if you don't know what Turing Complete means, it means there's a Turing machine that's just as powerful as it. In fact, it means there's a one-to-one correspondence between, say, for example, your neural network, providing that's recurrent, and the Turing machine. So if I say, okay, it's Turing Complete, that means it can do everything and be modeled as a Turing machine. And you said, well, no, it uses a probabilistic argument, that it uses fuzzy reasoning. Now, when we talk about fuzzy, what we're really talking about is actually something that you can easily argue is a form of classical logic. Now, if you didn't know that, there's a very standard, very simple argument to how to transform a fuzzy reason system into a classical system. Now, here's how you do it. It's very trivial. Okay, so follow me, Dan, right here. Now, you already had the notion of not understanding the basics of fundamental computation. Keep in mind, you said that you're talking about mathematical theories. Well, no, the decision problem has everything to do with computation here. I'm sorry, buddy, if you don't understand that. It's a very important thing to understand. When mathematical logic says something about being undecidable, that's the same thing as me saying, now keep a note and listen very carefully. If I say a problem is undecidable, that directly is one-to-one correspondence with saying there's no algorithm for it. Now, when you say neural network, and we're saying, oh, it's fuzzy. Now, here's the basic understanding of how you can transform and understand that there's no power given to it by giving it fuzzy reasoning versus a classical logic. Now, here's how you do it. You assume that there's n-valued logic. So that means that your logic contains n values of truth. So it means there's a variation between 0 and n. So here's a very simple probabilistic argument. All you have to do is very simple. You make n approach infinity. If you assume that it is a real valued fuzzy system. Now, providing in real life, fuzzy systems aren't like that on a computer because we don't have real numbers on a machine. Real numbers aren't things that we can compute. We can represent them symbolically, but if you're talking about n-valued as a numeric, you can't actually put real numbers on a computer. You can use floating values. Now that's a finite number. So Dan, you're wrong, because all you have to do is you correspond n values to a floating point number. This could be a double, a long, it could even be a real number. And all you have to do is match a correspondence. All you do is say, okay, there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7, all the way on to infinity, or the largest value of your numeric system in terms of representation. So there's that argument dead out of the water. It is indeed Turing Complete. That means all I have to do is say, okay, here's this in fact, you can just use propositional logic, the weakest of all mathematical logics, to represent a basic fuzzy logic. All you have to do is to just assume a bunch of axioms, and you chug it off and you match it as an n-classical propositional logic. That's all you have to do. Now, when we go one step further, when you talk about determinism, you're assuming a lot of things. You don't understand what a Turing machine is actually about then. Turing machines can be deterministic, they can be non-deterministic. It depends on how you define a Turing machine. For example, you can have multi-tape Turing machines, you can have a quantum Turing machine. The Turing machine is a very, very vague term, and it can apply to any deterministic, non-deterministic machine model, because it's the most powerful one that exists, okay? So it means, and for you to say with much arrogance that your system is more powerful than a Turing machine, then that merits a proof. Like I said, never has been done. So I'm sorry if you don't understand that, Dan. Secondly, when you talk about this in a very simple way, you seem to be proposing that I don't understand things when you yourself don't understand the basics of computation. You're approaching the concept of artificial neural networks. Now, maybe you don't even understand what a neural network actually is. Because, okay, here's how a neural network works. You have a bunch of data. You model it as a network. And that neural network is going to be using some sort of fuzzy reasoning. Now, the way you want to do it is naturally you want to massage your data so that you can make a nice network that can be able to solve problems in emergent fashion. Now, when I say emergent, that means it comes to an answer much more like a genetic algorithm would. So, when we talk about that, this can be a potential form of machine learning, which is very important in understanding any expert systems. In fact, you give me some good examples, and you talk to me like I don't know what I'm talking about. Well, buddy, you're wrong. I don't think you understand how much I actually know about this subject. You're actually talking to somebody that actually teaches this specific form of technology to children and people of all ages at a museum. So, for example, you're talking about missile guidance. In fact, I just talked about that today to a group, talking all about how heat-seeking missiles work, how the missiles work in trajectories. Maybe you don't understand that, Dan. I don't think you do. So, with that being said, you have a lack of understanding. As ironic as you say that to me, you do not understand. You do not understand, Dan. You need to go study some mathematics and some theoretical computer science before you can approach me and say, hey, buddy, you don't understand this. And when you don't even ask me any questions. So, when you go one step further and you say that it's only capable of finite determinism, you're ignorant of the subject. You're doing an argument from ignorance, buddy. You can't do that near me, because I will point out your BS faster than even you know it's coming. So, when you're talking about this, you need to understand the concept of deterministic Turing machines and non-deterministic Turing machines. This can mean a probabilistic model, which is very similar to what you're describing, a fuzzy model. So, with that being said, Dan, you're wrong. You may want to study this a little bit more before coming to me very arrogantly and quite rudely without having a firm understanding of what you're talking about. You talk about the Turing test when I was talking about Turing machines in my video. You talk about saying that Turing machines are no powerful than a neural network. That's just all BS. You never actually studied it. Go study it and then we can talk. Maybe I'll unblock you for being so rude to me. So with that being said, learn to be a little bit more polite to people that maybe know a lot more about a subject than you do. Because if you want to make good colleagues as a scientist, you gotta make sure you do it very politely. Because you come up to me asking about very specific things and you critique me for being arrogant. Now, I'm not being arrogant, I'm just telling you facts. Now, if you have a problem with facts, then go live in a cave. So with that being said, Dan, I'm sorry if you do not understand the concept of computation. Theory of computation is a very difficult field, but it's a field that you do not understand properly. With that being said, have yourself a beautiful day, everybody!